Wave propagation in lossless medium. What do you mean by propagation? When wave is going to propagate? When wave is the function of time. Okay. And we have seen that wave propagation is going to take place due to displacement current. That displacement current play the main role there. And what is meaning of the perfect dielectric? So here, or we can call this one as the lossless medium also. So finally, if you see that, what is the condition here? Sigma, that is the conductivity is 0 and epsilon is epsilon naught into epsilon r, mu is mu naught into mu r, and conductivity is already 0 and it can be written, it is much smaller than omega epsilon. Okay, so this in the next derivation we'll see that we have ratio of sigma by omega epsilon. On the basis of that, propagation constant alpha and beta, that is the propagation constant or attenuation constant, and beta is the phase constant. We are going to see how it's going to depend. Okay, let's see about this wave propagation in the lossless medium. So now here, this equation already we have seen earlier, the general format we have seen, we have del square E equal to mu epsilon dou square E by dou t square. So that free space is also called as the perfect dielectric. So in that case, mu will be mu naught, epsilon will be epsilon naught. We can write dou square E by dou t square. So now in the previous derivation, so that you can see it is available. Okay, that video you can see. So now here, this also can be called as like a harmonic wave propagation. Okay, so here in place of dou by dou t, okay, we are going to write j omega. So finally, you are seeing that here we have dou by dou t, and so that is j omega, and dou square by dou t square. So j omega came 2 times. Otherwise, we can see in this form here, if you are considering E equal to U naught e to the power j omega t, then differentiation of E with respect to t is E naught and is constant. So differentiation of e to the power j omega t is the j omega into e to the power j omega t. So finally, you are seeing that here j omega, if we'll take separate, then we have e naught e to the power j omega t. So that is equal to what? Capital E. So finally, now here we have expression del square E equal to minus mu naught epsilon naught omega square E. Okay, now we have taken left side. So finally you have del square E plus omega square mu naught into epsilon naught equal to 0. So now this one we are going to compare. So this E, capital E is also here. So this equation we can write in the form of del square E plus beta square E equal to 0. So finally here beta is equivalent or equal to what? Now we have written omega square mu naught epsilon naught. So this is the beta square. Okay. So now beta, how will write? Root under omega square mu naught epsilon naught. So finally omega is square root is omega. So we have root under mu naught epsilon naught. So this is the part here. So finally, if you see that if wave is going to propagate in the z direction, so we have seen earlier, so that is x and y component as well as z component, that is x and y components means dou by dou x and dou by dou y is going to be 0. And the z component of the electric field and magnetic field is going to be equal to 0. So on the basis of that, now here we can write for the that is the x component of the electric field here, dou square Ex by dou Z square minus beta square Ex. Similarly for the y component. So we can write similar kind of the expression for the magnetic field also. So in case of magnetic field, what we have to write? Dou square Hx by dou Z square equal to minus beta square, okay, Hx. And in case of y direction, we'll have dou square Hy by dou Z square equal to minus beta square Hy. So now here we are going to consider any one component, either y component or x component, anyone we can consider. And main purpose is here that we are going to see that electric field component here by using we'll take the concept of the real term. And here what you are seeing that in this way, it is the function of only a space. It still doesn't have time domain here. Okay. So for that purpose here we are considering Ey equal to A1 e to the power minus j beta z plus A2 e to the power plus j beta z. So where A1, A2 are two arbitrary complex constants. So now this equation 5 we are going to multiply with e to the power j omega t and we are trying to find its real term. Okay. So we have here in this situation what we have Ey we have considering here. So that is a A1 e to the power minus j beta z plus A2 e to the power plus j beta z. One is along the positive z direction and another is along the negative z direction. So now this is being multiplied by e to the power j omega t. So finally, here we are writing e of j comma t. Okay. So that this equation, which is the function of the z, is being multiplied by e to the power j omega t. So here exponent is being added together. So finally here one exponent we are getting omega t minus beta z. Okay, due to these two. And here we have omega t plus beta z due to this and this one. And you know about e to the power I theta value is what? Cos theta plus I sin theta. Okay. So where cos theta is the real part, sin theta is the imaginary parts. So here e to the power j omega t minus beta z is expanded. And here also e to the power j omega t plus beta z is expanded. So finally, we required only real part. So we have taken this one is the real part and another real part is this one. So now finally we have equation number 6. And earlier we have this equation for the beta. So from there, what we have? Beta equal to omega root under mu naught epsilon naught. So finally, now we can rearrange here beta by omega equal to root under mu naught epsilon naught. And previously we have seen that speed of light c equal to 1 by root under mu naught epsilon naught. So that's why here we'll take the reciprocal of this. So we have omega by beta equal to 1 by root under mu naught epsilon naught. So finally this omega by beta is going to become the velocity of the light. So this one also we can see like this, omega is 2 pi f, beta is 2 pi by lambda. This is equal to f into lambda. That is the velocity of light here. Okay. So and velocity of light is how much? 3 into 10 power 8 meter per second. And here since medium is lossless, so attenuation doesn't occur. Generally attenuation means that wave will be attenuated by the factor e to the power minus alpha z. So here attenuation doesn't take place. So alpha is 0. So e to the power 0, anything is what? 1. So that's why we have component. There only we have phase constant. We don't have alpha. That is the attenuation constant. So now the equation, what we have seen in the equation number 6, it is combination of two waves. One is traveling as we have discussed earlier along the positive direction, another in the negative direction. If A1 and A2 both value will become equal, then it is going to give the standing wave. So a standing wave, what is meaning of a standing wave? If one wave is propagating like this, okay, so another wave after returning, okay, that returning wave is going to come in this way. So this is going to form the standing wave. So that means A1, A2 is equal. A1, A2 is equal means amplitude of wave which is traveling along the z direction and the amplitude of the wave which is returning and going to travel along the negative z direction. So both have same amplitude. So finally it is being going to appear as the standing wave. So both are going to be cancelled out. One is positive, one negative simultaneously. So it is going to appear as the standing wave. Suppose, for example, you have +3 -3. So both will be added. It's going to appear as the 0. So here this is the positive, negative. Again here, this will become positive. This is the negative. So like this process takes place. So any doubt is there, you can write in the comment and like, subscribe, support our channel. Okay. Thank you. Thank you very much to watch this.